Alright guys, so this should be the second video that you're watching today on Friday, January 12th. Part 2 is all about the solution sets of an inequality. So one of the things that we're going to see is that the solutions to an expression, to a equation, and to an inequality are all different. So I think that's a good central question to start us off with today is, how do the solutions of an inequality differ from expressions and equations? All right, so the essential question for today: how do the solutions of an inequality differ from expressions and equations? So just as a reminder, an expression, I'll write this here in the question section, an expression is something that looks like maybe 3x plus 5. It doesn't have an equal sign, it's just terms. Whereas an equation would look something like 3x plus 5 equals 7. And so an equation does have an equal sign, and we can solve for x and that will tell us exactly what x is equal to. That would be the one solution for x. However, for an inequality, what you're going to see today is that there are going to be several numbers that are going to be a possible solution for x in an inequality. Because in this example, 3x plus 5 is greater than 7, x could be equal to 1, it could be equal to 2, it could be equal to 3, and all of those values will be true. Whereas in the equation, 3x plus 5, the only answer that x can be is 2/3. And we'll go over that kind of stuff a little later, but that is how expressions and inequalities differ from one another in equations. And then in an expression, 3x plus 5, well, we can't figure out what x is equal to. The only thing we can do is simplify it down to its simplest terms by adding the like terms. So with that introduction, let's go ahead and learn some new vocabulary. First thing here is a solution of an inequality. A solution of an inequality is a value that makes the inequality true. An inequality can have more than one solution, as we just talked about. The set of all solutions of an inequality is called the solution set. Go figure. So these inequalities, they're going to be able to have more than one answer to their x or y or z variable. So here is an example that we have. We're given the inequality x plus 2 is less than or equal to -1. And so we need to try to figure out what values are true for x. So that's why we have here, this table is broken up into 3 places. We've got the value of x, so the value that we're going to be plugging in for x into our inequality, x plus 2 is less than or equal to -1. And then so we are going to be plugging those values of x in, this -2, -3, -4, and seeing if our inequality comes out to be true. And now this has already been done for you, so let's go ahead and just check it, just review this, check it out. So here I've got -2 for this value of x, and if I go to my inequality and plug in for x -2, which is what they've done here, then now I have the inequality of -2 plus 2, and we have to see if -2 plus 2 is going to be less than or equal to -1. Well, -2 plus 2, because those are opposites, that's just going to add up to 0. And then we're not doing anything to the other side on the -1 because we didn't add anything to the left side of the inequality. So we're not going to do anything to the right side. The only thing we did on the left side of the inequality over here is that we simplified it by adding the like terms. -2 and 2 are both integers, so we can add those like terms together. So then after that, we get that 0. The statement reads 0 is less than or equal to -1. Well, 0 is not less than -1 because if we were to look on a number line, 0 is more to the right of -1, which means that it's going to be greater because the number line travels from least to greatest. So that is not a true statement. 0 is not less than or equal to -1, so therefore we would answer the final question on our table. Is the inequality true? As no. Plugging in -2 for x gives us 0 is less than or equal to -1, which is not a true statement, so we would put no. The inequality is not true. But as you can see, we do have two values that do make the inequality true here. Let's check them out. If we were to plug in -3 for x, we'd have -3 plus 2, which simplifies down to -1, is less than or equal to -1. Well, -1 is not less than -1, but -1 is equal to -1. And remember that less than or equal to sign means that it can either be less than -1 or it can be -1. And so that does make the inequality true. Is the inequality true? Yes. Same thing goes for -4. -4 plus 2 gives me -2, which is now less than -1, so that is true. And then if we were to keep going, we'd see that -5 would give me -3, which is less than -1, and that would be true. And you could probably imagine that any number less than -5, we were to keep going, would end up making all of these true. And so we're actually going to show that a little later on a number line to demonstrate all of the solutions that are true for x. So here we've got example 2. Example 2 because example 1 was on part 1. And what example 2 wants us to do, and before we move on to example 2, let me go ahead and put a question up here for you guys. How can we use a number line to represent all of the solutions of an inequality? And then just a reminder too, guys, if you are totally lost as you're watching this, please try to ask the people around you. Ask me. I'm walking around. I might be helping somebody else, but I will get to you eventually. So if you're totally lost, make sure that you are asking questions. Okay, example 2, checking solutions. So the directions here are told, tell whether -2 is a solution of each inequality. So what we're going to do is we're going to take this -2 and we're going to plug it into the variable of each inequality. In this case on A, we're going to have -2 minus 5, and we're going to check to see whether the solution of that is greater than or equal to -6. So here I'll put for y, I'm going to plug in -2, and then I'm going to do -5 and check whether that really is greater than or equal to -6. Well, -2 minus 5, that's going to give me -7, because if I have -2 and then I'm subtracting even more, making it more negative, it's going to become -7. And is that greater than or equal to -6? Well, I know it's definitely not equal to it, because -6 is only equal to -6. And is it greater than -6? Well, the number itself makes it look like it's greater, but we got to remember that on a number line, -6 is more to the right than -7, and because the number line travels from least to greatest, then that must mean that -7 is less than -6, and that also makes sense because -7 is more negative than -6. So this is not true, and what you can do to represent that this is not true is you can write a line, write a diagonal line right between those symbols, and that shows me that this is a false statement. -7 is not greater than or equal to -6. Let's do another one together. So I'm going to be plugging in -2 over here in for y into question B. And then so that's going to be -5 and 5/10 times 2 negative. And we're going to check whether that is less than 14. So we're going to see whether -5 and 5/10 times -2 gives me a value that is less than 14. Well, 5 and 5/10 times 2 is going to leave me with 110, but then I also have one number past the decimal here, so I'm going to move my decimal in one place, and so that leaves me with 11. And is it a positive or a negative 11? Well, negative times a negative leaves you with a positive, so it's going to be a positive 11. And is that less than 14? 11 is less than 14. It's more to the left on the number line, and so this is a true statement. So what I would write here is yes, this is a true statement, whereas over here I would put no, that is not a true statement. So that is how you check whether a number, an integer, actually is a solution to an inequality, is you can plug that number in, and then you're going to check, is the statement true? Is negative 7 greater than or equal to negative 6? In this case, no, it was not. Over here, is 11 less than 14 when we plug in negative 2 for y? Yes, it is. And so negative 2 is a solution to this inequality, is not a solution to the first inequality, but is a solution to the second inequality. So if you're lost on that, please make sure you're asking me a question about it. You've got some to try on your own here. It's telling you to check whether negative 5 is a solution set of the inequality. So just like we did up top, you're going to be taking negative 5, plugging it in for the variable values, and then checking to see whether whatever it simplifies into on the left side of the inequality is a true statement to whatever integer is on the right side of the inequality. So go ahead and do that on your own. If you need some help, raise your hand. I'll come help you out. And then have me check your answers. Check your answers as you go, so that way you know whether you're understanding it or not. After you finish this on your own part, please move on to the lesson